Okay, so we're going to go over this not in full detail, just quickly, make sure that you have the right general idea. So in A versus B, who wins that matchup? B. A versus C, A wins. A wins versus D and versus E. And then B versus C, C. B versus D, tie. B versus E, B. C versus D, C versus E, E. And D versus E, D. Okay, so when we tally them up, we have A gets 3 points. B gets 1.5, 2.5. C gets 1, 2. D gets 0.5, 1.5. And E has 1. Yeah. So the winner is A with 3 points. All right, so now suppose that right before the draft, it's discovered that Castillo has accepted a scholarship to medical school, and he's not going to play pro football after all. Okay. But we don't care, right? He's our guy. We want Allen, right? Everybody agree? Doesn't matter. Shouldn't matter that Castillo's not in the running anymore. He's not our choice. Seems like it shouldn't matter.
But what if he was the one that? What if that was the one that gave A 1 extra?
Right. Yeah. Yeah. That's exactly what could happen. So what I want you to do is in your groups, I want you to do pairwise comparisons again. This time I just took out Castillo, right? So wherever C was, I just removed it, and I moved everybody below them up 1, right? So get rid of C, and these 2 votes now become A, D, B, E. So I get rid of C in the whole preference schedule, rewrite it, and this is what my new preference schedule looks like, okay, with C gone. So I want you to do it again, pairwise comparisons. Shouldn't take as long because now there's only 4 candidates, fewer comparisons. And see who wins this time. All right, so let's see here. A versus B. A is going to get the first 2. B gets the next 11. A gets 1 and 1, and B gets 4. So B wins that matchup. Who wins A versus D? A. Who wins A versus E? Who wins B versus D? Tie again. Okay. B versus E? B. D versus E? Which one? D. Okay. All right, so A has 1, 2 points. B has 1, 2.5 points. C is out. D has 1.5, and E has none. Okay. So B wins now with 2.5 points. So we wanted Allen. Allen was our man. He's the guy we wanted to recruit. And then Castillo dropped out, and now we don't want Allen anymore. We want Byers. That's kind of weird, right? So this is a drawback of the method of pairwise comparisons. It's kind of an odd result, and it illustrates a violation of a new fairness criterion called the independent of irrelevant alternatives criterion. Okay, sometimes I refer to this as the dropout criterion. Okay. If candidate X is the winner of an election, and in a recount, one of the non-winning candidates either withdraws or is disqualified, X should still win the election. If a non-winning candidate drops out, the winner should remain the same. So we can sometimes violate the dropout criterion using pairwise comparisons. So it's one drawback. Another drawback of pairwise comparisons is illustrated in this example. We have a hockey team on a road trip. They have to decide where to eat lunch. It's a very heated topic. So the coaches institute a vote, and this is the preference schedule. Determine the winner using pairwise comparisons. So in this case, we have three matchups, A versus B, A versus C, and B versus C. So in A versus B, A wins, they get 4, B gets 2, A gets 6, B gets 3, so A wins. A versus C, A, C, C, A, so C wins. And then B versus C, we have 4, 2, 6, 3, B wins. So A has a point, B has 1 point, and C has 1 point. So we have a three-way tie. You could do that. Yeah. There is no tie-breaking rule. We haven't learned a tie-breaking rule. Yeah. We could break it using any of our three methods, right? We have three other methods of counting votes. We have plurality, Borda count, plurality with elimination. So here's a good chance for you to practice the three methods we've learned in the past two classes. So who wins using each of these three methods? Okay, so for plurality, we just count up first place votes. So we look at the preference schedule and we say A has 4, B has 5, and C has 6. A has 4, B has 5, C has 6 first place votes, so C is the winner. In Borda count, we assign points, right? So because there are 3 candidates, then first place gets 3 points, second place gets 2 points, and last place gets 1 point. And then you multiply the number of points times the number of ballots, right? So 3 points for first place, and A has 4 ballots where they're in first place, so they get 12 points. 2 times 3 is 6. 6 times 3 is 18, and 3 times 3 is 9. 2 times 4 is 8. 2 times 2 is 4. 6 times 2 is 12. And 3 times 2 is 6. And then 1 times 4 is 4. 1 times 2 is 2. 1 times 6 is 6. And 1 times 3 is 3. So when you add up each candidate's points, what do you get for A? 32. What do you get for B? 29. And what do you get for C? 39? 29. So A wins. Okay. And then plurality with elimination starts with plurality. You just write down the number of first place votes each candidate has. And then you say, okay, well, that's a total of 15 votes, right? 15 people voted in this election. So to have a majority, how many votes do I need? 8, at least 8. Does anybody have a majority? No, so we eliminate the candidate with the fewest first place votes, which is candidate A, and determine who gets those 4 votes that A used to have. You go back to the voters, right? You go back to the preference schedule and you say, these people who had A in first place, they had B in second place. So if we're getting rid of A, we'll give their votes to B. So B gets +4, which is 9. And that's a majority, so B wins with plurality with elimination. So we're kind of in a pickle, right? When I did pairwise comparisons, I had a 3-way tie between A, B, and C. We have 3 other methods we can use to determine the winner of an election, and we got 3 different winners. Now what? I don't know. So this is to help illustrate the fact that there is no consistently fair method to determine the winner of an election, because it all depends on what method we use, who wins. So how do we decide what method to use? Do we vote? What method are we going to use, right?
Depends probably on the amount of voters and
Yeah. Somebody or some people have to decide what method to use ahead of time. And we have to come up with a tie-breaking rule ahead of time. There is no hard and fast, this is what you do. Whoever is running the organization that needs to have a method of voting gets together and says, this is how we vote, and this is how we break ties.
So no matter what, they don't have the information prior to making that decision, so they can't determine the one ahead of time.
Yeah, hopefully. Yes. Yeah.
Will we be able to tell, like, if you see the voting going on, be able to tell whether the criteria is, like, you see voting going on, we look at it and they have certain words, keywords, oh, you know that's.
I don't think you'll need to. I mean, I'm not gonna ever like.
No, I mean, just in general.
Like in real life.
Oh, in real life? Oh, yeah. So,
Like something like the
Yeah.
Electoral College.
oh, the Electoral College is a weighted voting system which actually we're going to talk about in chapter 2. So that's not even one of these 4. Yeah. But a lot of people have suggested instant runoff voting as a method to replace the Electoral College, which is plurality with elimination. It's just a different name for it. And you would never, there are no keywords. You just have to read the description. You go instant runoff voting. We eliminate candidates giving their votes to the next candidate in line until someone has a majority. And you go, oh, that's the pairwise, that's the plurality with elimination method.
But that's how you identify them, it's just how they're
Yeah, you just read the process and say, oh, I know that method.
Also, each process has instructions.
Yeah.
And that's how we do it.
Yeah. Yeah, if you read about something in the news and they say such and such a method was used, if they don't tell you what it is in the article, Google it. Read the description, and then you would say, oh, that sounds a lot like, one of these that we know, going by a different name. So, conclusion made from the above example. There is no consistently fair method.
process needs to be set for both.
Yeah. So yeah, it's important to set the no consistently fair method. It's important to set the method and tie-breaking rules ahead of time. So it's kind of like the Electoral College, right? The Electoral College sometimes produces things that people perceive as unfair, right? Sometimes we have a winner who lost the popular vote. That can be perceived as unfair, but it is the method that we use, and we all abide by it to avoid chaos, right? Because there is no method that will always produce a clear, fair winner. Okay, so it's important to set the method and a tie-breaking rule ahead of time, and then we'll all abide by it. The pairwise comparisons, it violated that dropout criterion. Yeah. Yeah, so it's not perfect. Yes. Yep. So one final drawback to the method of pairwise comparisons is that as the number of candidates grows, the number of matchups grows even faster. So for example, if you have 10 candidates, there are 45 head-to-head matchups. And if there are 100 candidates, there are 4,950 head-to-head matchups. Okay, so I'm going to teach you how to figure it out. You don't have to memorize it. Yeah. Yeah, you could have a computer do all the head-to-head matchups because that would be crazy to do it yourself. But how do we figure out how many comparisons there are, how many head-to-head matchups there are? So in order to figure it out, we're going to start with a seemingly unrelated question, adding up all the numbers from 1 to 99. Add 1 plus 2 plus 3 up to 99. Yeah, like, really? Do we really have to do that? No. So I'm going to teach you a cute little method for doing this. I want to add 1 plus 2 plus 3 plus blah, 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 plus 97 plus 98 plus 99. All the integers from 1 to 99. And I don't know what it adds up to, right? We're going to call it some unknown amount x. Now, if you add them in reverse order, 99 plus 98 plus 97 plus blah, 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 plus 3 plus 2 plus 1, what should that add up to? The same thing, right? You can add in any order you want, so that also adds up to x. So now I'm going to add my two equations that I've written down together. I'm going to do plus. So what's 1 plus 99? 100. What's 2 plus 98? 3 plus 97? 100. 97 plus 3? 100. 98 plus 2 is 100. 99 plus 1 is 100. And x plus x is 2x. X plus x is 2x. Okay. Including everything in between the dot, dot, dots, right? Because I've written down a whole bunch of hundreds here. If I had written this all out, 1, 2, 3, 4, 5, 6, all the way up to 99, and I wrote out this whole bottom equation, how many 100s would I have written down in this last line? 99. Yeah, because I have 1 to 99, right? So I would write down 99 100s. So what's another way of writing 100 plus 100 plus 100 99 times? 100 times 99, or 9900. I'm adding 100 to itself 99 times. The mathematical notation we use for repeated addition is multiplication. So 100 99 times equals 2x. So I have 9900 equals 2x. Divide both sides by 2. Right? Remember solving a basic equation? So the 2's cancel on the right and we get x. And half of 9,000 is 4,500. 4,950. This is all math. Yeah. So 4,950 head-to-head matchups. Oh, well, actually, sorry, this was an unrelated question. So when you add up all the numbers from 1 to 99, you get 4,950. So cross this out in your notes. We're not going to do that. So let's consider an election that has 10 candidates. A, B, C, D, E, F, G, H, I, and J. I'm going to count all the pairwise comparisons. I'm going to write them all down and count them. So let's see. I have to match A versus B, A versus C, A versus D, A versus E, A versus F, A versus G, A versus H, and A versus I. I and J. Okay. So that's all of A's matchups. Now I move on and I do B's matchups, right? But I already did B versus A, right? So I have B versus C, B versus D, B versus E, BF, BG, BH, BI, B versus J. Okay, so that's all of B's matchups. Then I move on to C. But I've already done C versus B and C versus A. So I start with C versus D, CE, CF, CG, CH, CI, CJ. Move on to D. I've already done D versus C, D versus B, and D versus A. So I start with D versus E, DF, DG, DH, DI, DJ. Move on to E's matchups, but I've already matched E against D, E against C, E against B, and E against A. So I start with E against F. So EF, EG, EH, EI, EJ. F's matchups. EF, we do have FG, FH, FI, FJ, FGH, GI, GJ, HI, HJ, and IJ. 45. How'd you add them all up?
I multiply 10 by 9.
Okay, so we have how many matchups in this first column? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. And then each column, we lose a matchup. Each one is one shorter than the last. So I have 8, 7, 6, 5, 4, 3, 2, 1. So for 10 candidates, it turns out I need to add up the numbers from 1 to 9, right? So for 10 candidates, add 1 plus 2 plus blah, 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 plus 8 plus 9. Now, there aren't that many here. We could just add them in our head or on a calculator, or we could use our little trick, right? We could do 1 plus 2 plus 3 equals x. Then write it backwards. 9 plus 8 plus 7 plus 6 plus 2 plus 1 also equals x. Add them. Each time I add these together, I get 10. Yes, I've written down tens here, sums of 10. There are 9 of them, right? Each time I add, I have 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 sets of 10. 9 times 10 is 2x. And you have 90 equals 2x. Divide both sides by 2. And you get x is 45. Sure. Yeah. Yeah, that's fine. Yeah. Yeah. So the length and the width are like the number of candidates and the number of candidates minus 1. Yep. Good. So in general, if you have n candidates, to find the number of comparisons, you multiply the number of candidates. So in our previous example, that was 10. We multiplied 10 times 9 divided by 2. So we do n times n minus 1 and divide by 2. So if there were 100 candidates, right? So we would do 100 times 99 over 2, which was 4,950. Mm-hmm. So for example, we have a round robin tournament. Every player plays every other player once. Could be, it's ping pong tournament. Okay. So imagine you're in charge of scheduling a round robin ping pong tournament that has 32 players. You get paid $1 per match. How much money will you make? All right, so you guys seem to really have gotten what we just did. That's great. So the number of head-to-head matchups would be 32 times one smaller than 32, which is 31, over 2. And that comes out to 496. So you can just get on your calculator. So you would make $496 because if you get a dollar per tournament, per match. Yeah. We're going to skip this practice. You can do it on your own later if you want. Oh, okay, I guess I got rid of it. So far we've studied 4 methods for determining the winner of election and 4 criteria for fairness of an election. So we only have a couple of minutes, so this is something that you should probably do on your own. I'm not going to collect it or anything, but this is going to be a really good way of taking everything we've learned in the past 3 classes, everything we've learned about voting, and putting it into a nice little summary style table. Okay, so these are your methods across, and these are your fairness criteria. I want you to take each method, write down its name and how you do it, write down its name and how you do it, and then talk about which criteria it always satisfies and which criteria it can sometimes violate. So it's just pulling everything together into one place. You have it on one piece of paper that you can use as reference. So you'll do that on your own because we're running out of time today. And that's it. Your homework is in my math lab.